Okay, let's start. Hello, my name is Jiawei Chen. I'm from PLCT Lab. Today I will talk about how to use FFmpeg as a benchmark to verify the performance for both GCC and LLVM. Firstly, what's FFmpeg? It's a widely used workflow that you can use it to encoding or decoding the videos. It's free and open source, and we use it to march on a RISC-V board, and to run it on RISC-V board, you should cross-compare it first. For GCC part, it's straightforward. You just set the --arc option to RISC-V, and it's also available for both x86 and the ARM. The important option here is the architecture option, like mark equal RV164GC, blah, blah, blah. And we set the optimized level to 03 to enable the RVV feature. Here we also use an option that bound in disable RVV, since the FFmpeg implement the RVV option for RVV intrinsic. So we don't use that here. We just enable the auto vectorize here. For LLVM, we need more additional options to set its library and explicitly set its compiler to clone and clone++. It's similar to GCC configure. And we need to prepare a source file video for test. Here we use the big bank body, famous video. We just clip it in 3 resolution and we extra 1 minute clips to as a test source file. To use FFmpeg decoding the video, we just add the dash benchmark option to make sure it generates the timing result. Here, the metric is R time, real time is the result what we want. It shows how long did the FFmpeg decoding. We also can use QMU to get the result, but it is not reliable for if you use simulator. So you should just use real board with it. We're testing on the Muse Pi Pro with K1 core that supports our RISC-V vector extension version 1.0. We test 3 times and use the average as a result. It's reproducible and fair. Here, the chat shows the result, and we recording the R time to compare. You can see it strictly that the GCC is cost shorter time than LLVM. And let's look in the detail. The GCC overperformed about 26% to overperformed LLVM. And even without RVV, GCC is better, and it get a 7% advantage. And here we have some known bugs. First, you can't use fast math with the test, since it will broken the FFmpeg. And the code size for GCC generator is almost 2 times larger than LLVM. We look around it and find that GCC will generate a lot of loop and unimplement instructions, but LLVM not. And the debug info size is much larger than LLVM. What's the future work? We want to look about how we improve FFmpeg test, and what if we use different LMO, and how to improve all the results. To summarize, we use FFmpeg as a real benchmark to compare GCC and LLVM. And on RISC-V hardware, GCC shows better result than LLVM, both with RVV and without it. But here are still some challenges, like code size, and we don't test on different real boards, since we only get K1 as the board which support RVV extension. We may try more RISC-V boards in the next year. Thanks for your listening.
So your LLVM versus GCC performance roughly matches a lot of stuff that we're seeing. One of the biggest things we've seen with LLVM is it really wants to use indexed addressing modes, which are incredibly expensive on most RVV hardware right now. So if you're looking to figure out what's going on with those index loads, because they are incredibly expensive, LLVM really likes creating them.
Also the LMO difference.
Yeah, so LLVM defaults to an LMO of 2.
Yeah.
But that also doesn't explain without a RVV.
Well, no, but that 7% is much closer to the number I would expect.
Oh.
I've seen that on the scalar side as well. But when you go into RVV, that the using of index loads and LMO of 2 tends to create problems. Yeah, Jeremy.
So I'm just curious. I would expect video processing to be highly vectorized.
Yeah.
And the difference, GCC, you're going down from what, 60 to just under 40. You're getting about 30.
You're not doing great.
You're not doing great. I'm just intrigued. If you ran these figures and compared ARC64 against ARC64 with SVE2.
I would expect a much bigger delta.
Yes. So, and the question is that the compiler or is it the vector architecture?
I think it's the latter. What I've seen of the K1 microarchitecture is vector unit. It's not very good.
Okay.
And I'll stop there.
Do you know anyone who's doing other better vector units?
Yeah. We do know.
Yes.
You said that there's an issue with code size with the NOPs. Are you certain that the NOPs are not essential for performance? Because as far as I understand, that can be very, very important for alignment.
Yeah, it's about 20,000 loop and on implement instructions in the I use like the lib.a files, and LLVM doesn't.
Okay.
What's
so,
really weird there is GCC by default shouldn't be doing code alignments for RISC-V. By default, I think every microarchitecture specifies no code alignments. So I'm really curious where they're coming from.
Yeah.
Oh, well, for RISC-V, yeah.
Well, that's what it says in RISC-V.
RISC-V actually doesn't even align at 4 bytes, which was
Right, everything's default to
everything's 2 bytes.
So where those knops are coming from, I think is a really interesting question.
But the I have a theory that they could be from these aborts with GCC I mean, from my previous experience, there was this abort that GCC thought is an unreachable condition.
Yeah, we'll turn that into a trap.
It is a trap, basically.
Yeah, so it's not going to be a no-op, it would be an on
Yeah, so there are 2 different things, I think. But,
yeah, so there's something weird there.
Just out of curiosity, does FFmpeg have any like assembly kernels running for routines, or is it all just compiler vectorization?
Good question.
5, I don't think so.
Okay, that's good. I just curious.
For
Well,
RISC-V,
it's
I
a
don't
great
think
question.
so. For x86, it does.
I don't know about RISC-V, but I know that they have a culture of really caring about
Yeah.
assembly routines. So
Yeah.
I would imagine that they do. Or if they don't, they're working on it.
'Cause I know
Yeah, and one more point here is you should enable F-tree vectorize in FFmpeg configure. It's forbidden currently for.
Yeah, we know about that. The Sam was working on fixing that with FFmpeg.
Yeah.
Have you tried profiling? Like one version is extremely better in functions called extremely.
Yeah, it's going to the future work since we don't have so much time for this work.
Reach out because the performance counters on the K1 are not documented.
Yeah,
So if you want to get the cycle counts out of the
and
K1.
we're also curious about the turning about it.
Yeah, reach out, because I do know what the raw counters to get your cycle information are. So I'm happy to pass them along.
Okay, I think